Hello, I'm Larry Veilleux. I'm a solutions architect and lead the training and consulting services for automotive cybersecurity at SAC. I hope that you enjoy this presentation I put together on automotive cybersecurity and the ISO 24089 standard. In this 30-minute session, we'll go over the ISO 24089 standard, which addresses software update engineering activities which occur throughout the life cycle of vehicles. It's interesting that most of the attention these days is around ISO SAE 21434 and UNECE R155. So hopefully my coverage of ISO 24089 and UNECE R156 here helps the industry as both are mandated now. Finally, watch this all the way through and don't be a dummy like me, unless you're my passenger Vince. During this session, we'll cover an overview of ISO 24089, a comparison of ISO 24089 to ISO SAE 21434, since most folks are more familiar with the latter, and the details of ISO 24089, including discussions of its requirements, recommendations, and work products. In this section, I will go over the ISO 24089 in a little detail by discussing why it's needed, its associated regulation R156, its comparison with ISO SAE 21434, and finally, its documented activities. Note that ISO 24089 does not differentiate between internal combustion and electric vehicles, or even flavors of hybrids for that matter. In short, ISO 24089 addresses the update activities of E/E systems within road vehicles and applies to vehicles of categories M, N, O, R, S, and T that permit software updates. Today, E/E systems exist in large numbers for all types of vehicles. And moreover, since vehicles also include capabilities for communicating with mobile apps, navigation systems, and OEM dealership back-end cloud-based systems for telemetry and such, the risks are higher and more widespread. The International Standard for Road Vehicles for Software Update Engineering, or ISO 24089, was released in February 2023. It provides terminology, objectives, requirements, and guidelines related to software update engineering as a foundation for common understanding throughout the supply chain. By applying requirements and recommendations in this document, the following benefits can be achieved for software update engineering. Safety and cybersecurity are addressed in software update operations in road vehicles. Establishment of processes, including goal setting, planning, auditing, process monitoring, process measurement, and process improvement, and shared awareness of safety and cybersecurity among related parties. In recent years, vehicle electronic control units, or ECUs, and software are increasing in complexity and have become essential to the operation of road vehicles. This software is often updated to increase functionality and maintain the safety and cybersecurity of road vehicles. Today, in-vehicle software is updated in a workshop by a skilled person or automatically over the air, or OTA. With the increased frequency of software update campaigns, it is important to have individual vehicle configuration information. Therefore, the establishment and application of software update engineering is important to ensure software quality, cybersecurity, and safety. Similar to ISO SAE 21434, ISO 24089 requires that software update engineering activities occur throughout the life cycle of vehicles. Speaking of updates occurring throughout the life cycle of vehicles, this slide displays the OTA update frequency of major automotive brands between January 2022 and July 2023. Not necessarily the story that I would like to hear, though. Tesla led the pack with 45 OTA updates in 2022 alone, followed by NIO with 1 to 2 OT updates a month. Those two are what I would expect anyway. But on the lower side, BMW performed 4 updates in 19 months, Ford performed 5 updates in 19 months, and finally, Toyota only performed 2 updates in 19 months. Obviously, we all expect, or at least desire, that updates are performed more frequently. From a governing perspective, the UNECE has developed regulations 155 and 156, which are new cybersecurity regulations for vehicles. R155 is concerning a manufacturer's cybersecurity management system, or CSMS, and R156 is concerning a manufacturer's software update management systems, or SUMS. Soon, all vehicle manufacturers, OEMs, will need to comply with these in order to sell their cars in Europe and in Asian member countries for sure. For new vehicles from July 2022 and all production vehicles from July 2024. Compliance with the UN regulation number 156 is required by the European Union's General Safety Regulation, or GSR, for a vehicle type approval for all UNECE member countries. So UNECE R156 software update and software update management system defines requirements for SUMS, whereas ISO 24089 is the baseline for SUMS. ISO standards can prepare the value chain for compliance and associated work products, which are essentially documentation or evidences to serve as justification in court should something go wrong. Software updates, as per UNECE R156, have strong overlaps with cybersecurity. Unknown vulnerabilities introduced in software are usually discovered by hackers when something special happens, and this is then exploited as a route to launch an attack. Since almost all vehicle ECUs allow software to be reloaded, updates are a good way to fix software vulnerabilities. So OEMs must prove that they have a SUMS in place, they must demonstrate its effectiveness and use, and they must continually review and maintain them. This must be verified by a technical services agency and certified by an authority such as KBA in Germany. In UNECE countries, a car's E/E architecture with the specified cybersecurity properties cannot be approved according to the homologation requirements until it has gained the valid SUMS and CSMS certification. ISO 24089 defines how you can meet the conditions of R156. And just like ISO SAE 21434 defines how you can meet the conditions of R155. So it is required to have a compatible software update management system, or SUMS, in addition to a cybersecurity management system, or CSMS. ISO 28489 is not as long or comprehensive as ISO SAE 21434. For example, ISO 24089 has 34 versus 87 pages, 6 versus 11 normative clauses, 26 versus 42 work products, and 107 requirements and recommendations versus ISO SAE 21434, which has 118. Also, ISO 24089 has no annex items, has 14 versus 39 reference standards, and it's notable that R156 has 16 pages versus R155's 30. ISO 2489 has no permissions, and requirements and recommendations seem to be treated the same. In other words, both are included in the associated work products. Finally, ISO 2489 has no two-letter abbreviations such as RQ or WP, as does ISO SAE 21434. Instead, requirement and work product numbers are just taken from their respective subclause, such as number.3.n.number and number.4.number. So it's a nice way to remember it as that each clause's requirements and recommendations are subclause 3, whereas each clause's work products are subclause 4. This document describes the following activities. Each are addressed in separate clauses, and more on that next. Implementation of organizational level processes for software update engineering. Implementation project level processes for each software update project. Definitions of functions for the infrastructure and vehicle to support the activities and processes of this document. I've combined these two here, but they are addressed in separate clauses. Assembly of software update packages using functions in the infrastructure. Finally, preparation and execution of software update campaigns using functions in the vehicle and infrastructure. In this section, I'll go over the ISO 24089 in more detail by discussing its structure and its associated clauses. For each of these clauses, there are detailed requirements and recommendations outlined on what is expected to be implemented. The standard extends to show what are the anticipated outcomes in form of work products. As usual with standards, clauses 1 through 3 are informative as opposed to normative, which means that they do not specify any specific requirements. And those are followed by the normative clauses 4 through 9. This document is applicable to road vehicles whose software can be updated. It specifies requirements and recommendations for software update engineering for road vehicles on both the organizational and project level. The requirements and recommendations in this document apply to vehicles, vehicle systems, ECU, infrastructure, and the assembly and deployment of software update packages after the initial development. This document is applicable to organizations involved in software update engineering for road vehicles. Such organizations can include vehicle manufacturers, suppliers, and their subsidiaries or partners. It establishes a common understanding for communicating and managing activities and responsibilities among organizations and related parties. However, the development of software for vehicle functions, except for software update engineering, is outside the scope of this document. And finally, this document does not prescribe any specific technologies or solutions for software update engineering. The documents listed here are referred to in the text in such a way that some or all of their contents constitutes requirements of ISO 24089. Besides ISO 26262 and ISO SAE 21434, the bibliography lists more references to help meet the requirements holistically. As such, we can also consider other standards such as ISO 26262 when tackling safety risks, ISO SAE 21434, and ISO IEC 27000 series for managing cybersecurity risks, ISO 21448 for safety of the intended function, or SOTIF, ISO 10007 and ISO IEC IEEE 15288 for configuration management, and IATF 16949, ISO 9001, and ISO IEC 25000 for quality management. Finally, it can be stated that subjects such as quality management, information security, functional safety, and cybersecurity are closely connected to SOMs, and some requirements go hand in hand with each other. Terms and definitions in ISO 24089 are included in two sections. Section 3.1, which is just general terminology, and Section 3.2, which are terms related specifically to the software update operation. Note that unlike ISO SAE 21434, there are no abbreviated terms listed. So different industries often reuse the same terms with some slightly different meanings, and so it's always important that we're all on the same page. This table was produced from the ISO 24089 standard, but unlike ISO 24089 Figure 1, which I depicted previously, this table includes the subclauses listed too. So now it's obvious that there are 6 clauses, 4 through 9, and 24 subclauses. For example, Clause 5 project level includes 4 subclauses, 5.3.1 through 5.3.4. As we cover each clause following, I have included a smaller version of Figure 1 in the lower right-hand corner, highlighting the relevant section that's being addressed, along with also listing the associated subclauses in the upper right-hand section and work products in the lower left-hand corner. Each clause is the same structure. That is the clause number and name, followed by the standard subclauses. Number dot one are the objectives, number dot two are general, number dot three are requirements and recommendations, number dot three dot n with one or more requirements as the number dot three dot n number, number dot four work products with one or more work products as number dot four dot n. I have included an example from the document for clause 4 here. It is notable that subclause 3 for requirements and recommendations has more than one subclause. Clause 4 depicted here has 5 requirement subclauses. In this section, I'll go over the requirements, recommendations, and work products. I will accomplish this by discussing each clause individually. Let's start with discussing the requirements, recommendations or provisions, and associated work products. As I somewhat mentioned previously, a requirement means shall or must, of which there are 107 total, or 105 if you don't include the 2 may requirements. A recommendation means should, of which there are 10 total. A work product, which relates to the documentation of requirements, of which there are 26 total. As described previously, Clause 4 has 5 subclauses. Clause 5 through 8 each have 4 subclauses, and Clause 9 has 3 subclauses. It is notable that Clauses 6 and 7 essentially have the same subclauses for managing risk, managing vehicle configuration information, communicating software update campaign information, and processing software update packages. The difference being that Clause 6 addresses the infrastructure level, or how the update is stored and distributed, and Clause 7 addresses the vehicle level, or how the update is applied. More on that and the purpose of each clause following. Speaking of work products, here is the complete list of 26. Note how the middle digit for each work product subclause is always a number 4. Similar to how the middle digit for a requirement subclause is always a number 3. This list is an eye chart, but I've taken the liberty to include a reference to each of them on the associated slide for each clause. As we go through each clause here and following, each subclause 3 requirement is represented in the upper right-hand section. So for this example, for the organizational level, the governance, continuous improvement and such are subclauses 4.3.1 and 4.3.2 respectively. Remember that earlier in the presentation, I listed all the normative subclauses and their associated number designations. Also, each will list the associated work product in the lower left-hand corner, which is the case, in this case, are 4.4.1 through 4.4.5. And another reminder, requirement numbers are listed as subclause 3 and work product numbers are listed as subclause 4. Now, with all that out of the way, requirements for the organizational level are aimed at ensuring an organization has established governance for software update engineering. This clause is very similar to ISO SAE 21434 Clause 5. Governance determines what are the organization's responsibilities, compliance to standards, activities such as continuous improvement, information sharing, as well as supporting processes. To provide assurance that the objectives are met, an audit shall be performed. Requirements for the project level cover project management activities for the software update projects and managing information related to these projects. This clause is slightly similar to the ISO SAE 21434 Clause 6, at least discussing from project perspective. The information can include tailoring the projects accompanied with the associated rationale for that, interoperability between infrastructure and the vehicle system functions, along with preserving the integrity of the software as well as their metadata or update packages. Infrastructure level requirements take into consideration the functions assigned to the infrastructure for the software update campaigns. These functions include distribution, communication, information storage, and protecting them from a cybersecurity perspective. The requirements at this level aim at managing cybersecurity risk of the infrastructure, managing vehicle configuration information, communicating software update campaign information, in addition to processing of distributed software update packages. Busy slide, I know. I just wanted you to be thinking about all the different vehicle entry points that can be leveraged by the infrastructure to actually execute the software update. The entry point can be physical, requiring direct access to the vehicle, such as a repair technician connecting to the ODB2 ports, or it could be over the air, or OTA, with updates being pushed from the OEM backend or cloud to the vehicle from some remote location. The vehicle and vehicle systems level requirements establish the functionality in and for the vehicle or the vehicle systems to support the software update operation. The functionality deals with managing both safety and cybersecurity risks, generating necessary vehicle configuration information, communicating software update campaign information, enabling software update operation, and verifying software update packages, along with managing failures during the software update campaigns. Software update package requirements focus on the assembling of software update packages, verifying and validating the software update package's contents, coupled with identifying the classes of vehicles and vehicle systems to receive the package. Upon verification and validation of the software update package, the package is approved for release. So while Clause 8 here deals with creating the update, Clause 9 next deals with accomplishing the update. A campaign is an organized course of action to achieve a goal, in this case, to accomplish a software update cycle. For the software update campaign requirements, software update campaigns are prepared, executed, and completed. Here, the requirements further focus on the identification of targets of a software update campaign, collection of vehicle configuration information, resolution of targets into recipients, and distribution of the software update packages, and communicating relevant software update campaign information. I would like to close now by mentioning how SAC can help secure your future in automotive cybersecurity. Connect with our experts to streamline your compliance journey, fortify your cybersecurity defenses, and stay ahead of the evolving automotive landscape. Your security is our priority. Reach out now for a consultation tailored to your needs. So there you have it. I hope that you enjoyed this presentation I put together on automotive cybersecurity and the ISO 24089 standard. Please reach out to me at SAC to discuss how we can help your organization to ensure that your products are secure by design. Thank you for your time.